What's up, guys? Welcome back to another episode of the Dream Chasing 101 podcast. Today we're going to be tackling a very important topic, and with us today we have Daniel. I'll leave it up to Daniel just to give us a bit of context to who he is and what he does. So yeah, Daniel, go ahead.
Thanks, guys. I'm Daniel Kapelus. I am a medical scientist. My speciality is in genetics and vaccinology. I have done all my degrees at Wits University in South Africa, and I'm currently doing my master's degree in vaccinology, and I've had the privilege over 2020 to work on the Oxford AstraZeneca Vaccine trial here that was hosted at Baragwanath Hospital in Soweto, Johannesburg. And yeah, I'm very keen to share some knowledge about vaccines, about how they work, what they are, and hopefully we can just get a bunch of you guys who may have some concerns or doubts just to feel a little bit more confident in the situation and hopefully more confident in your decision to take the vaccine when it's available.
And Daniel, before we jump into that, we just want to get to know you a little bit better. So when you were growing up, when you were around 15 years old, did you see yourself doing this, or, what was your dream job back then?
I actually, throughout school, I dreamed of being an engineer. I just wanted to be an engineer. And, I realized, I think a lot of school kids have a very romanticized idea of what a lot of professions are. I realized I started an engineering degree. I started a degree in biomedical engineering at Wits. And I very quickly realized that engineering in reality is not what I thought it would be as a child. And that's why part of the reason I really love this podcast that you're doing, because it gives young kids a really realistic idea of what different professions are.
Yeah.
And I really think it's an amazing thing you're doing, man. So thank you for that. But yeah, so I the whole time, my group of friends and I, there were like 5 of us, the guys at school, we all wanted to be engineers. I wanted to, I just wanted to make cool stuff. That was like what I wanted to do. And I was always passionate about biology and medicine and the human body. So I decided to apply for a degree in biomedical engineering. And I started it, and it took me a couple of years. I did it for 2 or 3 years, and then just eventually got progressively more depressed with doing the wrong degree. I didn't like the way it was shaping me. I didn't like the direction it was going. I didn't actually enjoy the work. And eventually I had to, I managed to get the courage to say to my parents, guys, I don't want to be an engineer anymore. And this was a big shock to them. My parents are both lawyers. They're both professionals. They wanted me to do a professional type degree. And they said, well, what do you want to do? And I said, I actually just want to be a scientist. And my mom said, well, what the hell does that mean? What is a scientist? And I said, no, I want to answer questions that we don't know the answers to. And she said, okay, but when someone asks you what you are, what are you going to say? I'm going to say, no, Mom, I'm a scientist. And she said, that doesn't mean anything. So I transferred to a degree in in biological sciences with majors in human physiology and genetics. And that's where I found this absolute passion for genetics. Just the idea that there's this little molecule inside every living being that codes all organic life. And it's so small, but it's so significant. And it just blows my mind every day. And that's where I then finished my Bachelor of Science degree and then did an honors degree in genetics. And my research focused on population genetics, looking at the associations between genetic mutations and vaccine responses with a vaccine that is for a virus called rotavirus. And that's where I fell in love with the idea of vaccines, preventative medicine, and public health. And now I'm doing this master's degree.
Yeah, it's interesting. You mentioned how you had to kind of tell your parents that, this might not be for you. Was that difficult in a sense that you were scared of? You mentioned that they are like working professionals. Did you ever think that you're letting them down in any way? And how did you deal with that emotion?
Yeah, no, for sure. It was a really difficult conversation to have, and I wanted to have it for a long time before I actually did. I I got a real sense that that my parents were really proud of the fact that I was going to be an engineer, and my mom also, she spoke about her son going to be the biomedical engineer a lot. And I, it was also difficult for me to communicate what I was going to change to, because, as I was saying, saying you're a scientist is a very abstract thing. If you say you're an accountant or you're a doctor or you're an engineer, people know what that is.
Exactly.
But so I think initially, my parents had a few concerns about what was I actually going to be doing. Would I be able to support myself? What life was I going to have? And it took them a little bit of time to kind of understand what I am doing now. And I think there was definitely a bit of friction at the beginning, and it was really hard. And I kind of got to a point where the way I dealt with it was basically I had a conversation with an older friend of mine at university who had kind of gone through a similar process. And he said to me, Dan, at the end of the day, the only person who you have to live your entire life with is yourself. Everyone else in your life, in one way or another, will not be there forever.
Yeah.
And every decision you make, no matter how altruistic and selfless it is, every decision has to have an element of self-preservation. You have to consider your own mental health, your own well-being, and your future. And he said, listen, even if your parents desperately want you to be an engineer, you don't, and make the decision for yourself. And I knuckled down and I said, this is my life, and this is a decision that I'm comfortable with, and my parents will come around, they love me, they'll support me, and eventually they'll recognize that I've done the right thing. And they do. And now, they are exceedingly proud of me. They support me fully. My mum boasts way more about me being a vaccinologist than she ever did about me being an engineer. And especially with the pandemic, I think that my parents have realized how important it is to have people who want to do this kind of work.
And that brings me to the next question is, why choose the world of vaccinology? You mentioned, trying to make sense of, a molecule being within everyone and how significant that is. And then why stray into vaccinology and genetics specifically? Was there something that, because there's been a lot of chatter, some of the documentaries out there explaining pandemics, a couple years back. So it's not even like it happened during this time. This chat has been happening for a while. Did any of that ever influence you, or how did you come about to choosing this field?
So I actually never. The decision to go into vaccinology was quite a spontaneous one, actually, and being kind of in with my training in my undergrad as a molecular biologist, I was always interested in those documentaries about plagues and pandemics and infectious diseases. But it was more out of interest, kind of just for interest's sake. And it didn't really spark a professional interest. Because of the lesson that I'd learned about putting all your eggs in one basket with engineering and then realizing it's the wrong thing, I made sure that throughout my BSc, I kept a very open mind about what direction to go in. I didn't want to hedge my bets on anything. The one thing I knew is that I wanted to do something with genetics, because genetics just fascinated me. And I think the biggest thing that I realized thinking back, and this is the best advice I can give to any university kid who wants to know whether or not they've got the right major or the right thing, is every single day when I had a genetics lecture, I was never bored once. And every day I learned something new that fascinated me. And I would go home and, without it feeling like a chore, I would just start reading stuff. And I was so excited to learn. And when when a subject of yours, it doesn't matter if it's science, law, it literally doesn't matter what it is. As soon as it ignites that excitement to learn, and you stop feeling boredom, or, you don't want to fall asleep in your lectures, it means you're on the right track. And then I became very interested in a field called population genetics. And what that looks at is it looks at genetic trends in populations. So, for example, we all have the same genes in our body, right, in our DNA. But for each gene, there are many different variations of that same gene. And that's, for example, look at eye color, right? Everyone's got eyes that effectively work the same, but everyone's eyes look different, right? So I really enjoyed understanding why different populations have different trends with what they look like and how their bodies work. And, and with that, I started doing this research into rotavirus vaccines, because I was reading, rotavirus is a virus that causes a really bad stomach infection in children, typically under 5 years old. And there is a rotavirus vaccine. There were a couple that were released in 2009-ish. And the one that we use in South Africa, and it's quite commonly used in sub-Saharan Africa, is called Rotarix. Now, Rotarix has really, really, really good results in Europe and North America. But as soon as you come into sub-Saharan Africa, that efficacy drops substantially. And we don't really know why. And what my supervisor was looking at is there a genetic trend that is causing the vaccine to be less efficacious in our populations in sub-Saharan Africa? And through that investigation, I became fascinated with the concept that vaccines and medication in general can work so well in one population and so badly in another population when, ostensibly we're all just the same people, right? And that then, my supervisor is part of a consortium called ALIVE, which stands for the African Leadership in Vaccinology Expertise. And they run this master's degree, which is a Master of Science in Medicine and Vaccinology. And it's a really cool master's program. There's 4 universities in the world that do it, and WITS is one of them. And it's amazing to see a South African university establishing itself as one of the global leaders in vaccine science. And she said to me, Dan, if you're interested in vaccines, do this master's. It's really cool. And here I am, and I couldn't have made a better choice.
And, you basically came into this from the outside. So it's not like you always had the idea of doing this. So when looking at, our general perception of vaccines, once you journeyed into this and, became qualified in this field, did you ever have, perceptions that you previously had about vaccines that had to, or that went through a change? Did you see vaccines differently as you were journeying deeper into this field? Because obviously, for the general public who don't have much knowledge on this, we often question, science, and there's, all these questions that need to be answered. So after gaining and, journeying through this field, did you ever, change perceptions or ideas of vaccines?
So I think the difference was quite subtle with me because being kind of always having an interest in the biological sciences and always being involved in the biological sciences, I knew that vaccines worked. I knew that they were safe. I never had doubts about whether or not people should take them. Yeah. I think the way that my perception shifted was more about the real importance of vaccines. Before it was kind of, these are things that we need to take and they really make a big difference. But now I really understand how they work and why they're so important. And I understand a lot of the history a lot of the history behind vaccines and their development and the impact that they've had on public health globally. One of my favorite things to show people is a picture of a polio ward from the 50s. And you see this huge ward filled with iron lungs and people sitting in iron lungs. And that space now can be used for labs, for other wards, and I think there's one person in the world left on an iron lung. And that's because we had polio vaccines. And that was kind of the big shift with me was realizing that with the way the world's population is growing, with the fact that we will never get rid of viruses, we'll never get rid of bacteria, there will always be infectious disease. And what this pandemic has showed us as well is taking a route of treatment rather than prevention is not good enough. We don't have the infrastructure to treat everyone. And what I've now been shown is that preventative medicine is the future. It has to be.
100%. And, just for the general public, can you explain to us the purpose of a vaccine in general? So what's the core value, or the core purpose of a vaccine, in simple, layman's terms, if you want to put it that way?
Yeah, for sure. The point of a vaccine is to take a pathogen, which is any kind of bacteria or virus or whatever that can infect you and give you a disease, and it wants to train your body so your body can learn how to fight that pathogen specifically. So what it does is that then your body gets all this training, it takes a piece of that pathogen, it learns from it, it studies it, and it develops an immune response. And then your body tucks that immune response away, and it kind of stores it like in a memory bank. And then if you ever encounter that pathogen again, so if you get exposed to it through natural infection, your body says, hey, I recognize this thing, and I know exactly how to fight it. And it prevents you from getting the disease.
Yeah, I think that's, sometimes amongst, the vast amount of knowledge that's, put out on the internet, sometimes it's like a simple definition that sometimes is missing, and then people kind of stray into the abyss, assuming and also just not really reading the simple meaning of what this is.
Yeah, and I mean, I have a huge problem with the scientific world in general, where I feel like scientists are really, we're amazing at discovering and putting out new information, but scientists generally are really bad at talking to lay people. They're really bad at talking to people in simple terms. And, there's so much information out there. I mean, like, all of these major journals have made all of their stuff open access, but it's all really technical, complicated information that if you don't have a background in that area, you're not going to, it might as well be Greek, And one thing I'm really passionate about is making science more accessible to people. And I think it's really important that with basic principles in science that are really important in everyday life, like vaccines, it's really important that everyone can have a basic understanding and know what's going on.
And do you think that contributes to, there's a general, sometimes it's mistrust, sometimes it's just lack of understanding, but do you think that contributes to the skepticism in the science world from people outside of that world now looking in and listening to, various people talking, the fact that we don't understand it? Do you think that is a major contribution to people being so skeptical of it?
I think that is the biggest contributor. I mean, if you look throughout scientific development throughout history, but also just generally in terms of the way people interact with each other, it's very natural to have mistrust or fear for something that you don't understand. I'm actually listening to a very cool podcast on Galileo, who was the kind of late 1500s, early 1600s scientist who really pushed the theory that the Earth revolves around the sun and not the sun around the Earth.
Yeah.
And the backlash that he got was enormous, because it was like, how could you say such a preposterous thing, And, now we look at something like that and we're like, oh, of course the Earth goes around the sun. But the principle of mistrusting that is exactly the same as the principle of someone saying, well, how the hell can I trust this vaccine? I generally in schools, I did biology for matric. We had maybe like 1 or 2 lessons on what a vaccine is, not really much. Even in my BSc, we did a lot of immunology, but not a lot on vaccines. And med school as well. Like, I've got a lot of friends who are medical doctors, and in my master's degree now, there are 4 medical doctors doing it with me. And they've said, the level that we've gone into in immunology and in vaccine theory is infinitesimally higher than what they went through at med school.
Yeah.
So there is a very big problem with a lack of communication and education about vaccine theory and science in general. I think another contributing factor is the fact that a lot of scientists struggle to speak to lay people. So a lot of scientists can often come across as I think quite condescending or arrogant, and no one wants to feel stupid, and there's no one wants to feel like they don't know something, or I think there's a fear, especially in today's world, about being wrong. So a lot of people are very scared to have a conversation with the scientist in case the scientist says, how can you not know this? It's so easy.
Exactly.
So treating everyone with respect and being able to communicate on various levels of skill is really important.
Just a quick question. Do you think that should be something, not necessarily like a module in studying in these fields, or do you think that should be, just a side little thing that you need to actually do just to ensure that you're actually helping the science world out by learning how to communicate and spread the word more respectfully, if you want to put it that way?
I definitely think so. I mean, I think that a communication 101 course would be great for a lot of left brain scientific people. And it's so easy to talk to someone when you can speak the language. You can use the lingo and the terminology, I definitely think that a lot of people need a little bit of help in that regard.
And moving into, you mentioned that you were involved and you did some research on the AstraZeneca vaccine that was trialed here in SA. Can you explain to us that process, and then maybe take us deeper into the actual science behind the vaccine?
Yeah, for sure. So this the vaccine trial was, it was a huge privilege to be able to work on it. In terms of doing a master's in vaccinology, it's been real on the job training. So so it was a real opportunity for me. And it's really interesting to see how the scientific community adapted the way that we do clinical trials. And so usually, and there's been a lot of talk about how usually vaccines take 5 to 10 years to develop, and how did we get this out so quickly? And that is true. But a lot of the reason why previous vaccine trials can take 5 years or so is not necessarily because that's how long it takes to test a vaccine. It's because most vaccines are not developed in a state of urgency. Most of them are not developed in pandemics or epidemics. And in fact, the Ebola vaccine that was developed in just over a year has been really successful. And, I didn't really hear many people complaining about that one. But in a normal vaccine trial, when there's no pandemic, there's no epidemic, we do the phases of the trial one after the other. So you have your preclinical trials, you have your vaccine development, you design the vaccine. You have preclinical trials where you test it in cells in a lab. Those are called in vitro studies. And you do an animal model test, like with mice or rats. And the purpose of that is to say, is there some sort of immune response? And is the vaccine fundamentally, is it safe, right? So once you've gone through that, you can then provide enough evidence to start your clinical trials. So that's divided into 4 phases. Phase 1 is a very small phase that is focused entirely on safety. What kind of side effects are happening? We call them adverse effects. So we divide them into adverse effects and serious adverse effects. If there are serious adverse effects that are found in phase 1 studies, typically the vaccine often won't progress to phase 2. If there's a serious adverse effect that can be proved that it was not due to the vaccine, if, for example, one of the participants had an underlying condition, something like that, then the vaccine can progress. And there is in all clinical trials, there is an independent data monitoring board. And whenever there's an adverse effect, they review it, and they're not involved with the trial. They're not involved with the pharmaceutical company. They have no conflict of interests. They are independent moderators who make sure that the data is clear that the vaccine was not the cause of that adverse effect. And what generally happens is between the phases of the trial, so between phase 1 and phase 2, phase 3, they are they're these terms that we affectionately call them valleys of death of vaccines, where vaccines typically fail. Okay. And because you do the phases one after another, and you don't want to pay for your phase 2 if you don't know if your vaccine's got through phase 1. So the phases are funded independently of one another. So, and that's another reason why it takes so long, because you'll do your phase 1, you'll take your time analyzing the data. There's no rush. Once you've got the data, you can go and show that it needs to go to phase 2. Then you can take your time finding your funding for phase 2. And that process is very leisurely, and that takes a lot of time. It's not 5 years of rigorous vaccine testing, And what we did in these trials is, instead of running the phases, phase 1, phase 2, phase 3, we stacked them. So we had a huge population of people we were using in our trial. We divided them into numerous groups, and we were basically running the phases concurrently. So we had different groups that were looking at different aspects of the vaccine. So we had a phase 1 group that was looking at safety, phase 2 group and phase 3 groups that were looking at characterizing the immune response. Is it good enough? Is it going to give protection? And we basically then just got funding for all of them at the same time. And we had different teams of scientists running different phases of the trial.
And I think that's important to note, because there wasn't much information out on that either. Like, for me, this is all kind of new information to an extent. And also just the understanding of why, we have managed to put out, I don't know how many vaccines are currently approved right now, but there's the Pfizer, Moderna.
There's the Sputnik, Pfizer, Moderna, AstraZeneca are all approved, and Johnson & Johnson, I think, is going to be approved very soon.
So I think that's some of the information, about the actual trials are also not relayed to the public in the masses. So there's all these questions that the public has, and then we often find ourselves trying to find answers. And when you're trying to find answers on the internet, you can find some very obscured answers written by people who weren't even involved in the slightest. So I think that's very important to note that, and I think it's also a learning curve for everyone. Communication is something that needs to be improved in general amongst all the fields, from government to scientists to the public. And
for sure,
what are some of the things that, I mentioned how we've relayed information with you being so closely tied to this trial. When all the various, bits of information get leaked, even though it's not the true piece of information, how do you deal with that and try and educate people, knowing that you're not really in power to give, that knowledge to the masses?
Yeah, it's a really difficult issue, and it's kind of like as the team, we're kind of constantly trying to do our jobs and put out fires around. And I mean, you have to spend 5 minutes on social media to get a whole bunch of different theories and angles, and you mentioned there, how people disseminate information and talk to each other. And I mean, it's not even just people mistrusting scientists. It's, I mean, you look at, people, the way people speak to each other when they're behind a screen and a keyboard on social media, and it's volatile, and it's very difficult to have a discussion about things. And part of it's really frustrating when that the science is good, that you're doing a really rigorous job, and you see like the conspiracy theories and like the skepticism, and a lot of the trial information can't be released until the data is analyzed and finalized, because we don't want any bias or any pressure being introduced that could influence the outcome of the trial. We want it to be done in a really objective way that the outcome is based on the data, not based on any external pressures.
Yeah.
So during a trial, there's only so much information you can release. But I think that there is also, it circles back to also, I think, a kind of arrogance of scientists, where they kind of say like, listen, we know what we're doing and we've said that the vaccine's safe, so you must just take it and not question it, which is also unacceptable. But what I would plead with people is that they try and have a little more patience with us, with letting us try and get the job done, and then when we're at a point where we can safely and with confidence speak about the findings and the vaccines and the clinical trials, that we will. And it's it's difficult also when people have read something and they develop a strong opinion about it. It can be very difficult with one comment or one Facebook post to try and change people's minds. And there's also a lot of mistrust of government, for example. And I think that what a lot of people are confusing is the government is handling the dissemination of the vaccines, they're handling the distribution, but the government has not been responsible for the development of the vaccines. That's been done by pharmaceutical companies and scientists. So, yes, we have a history of problematic politics in South Africa, but, just because the government has let us down before, it doesn't mean you can't trust the vaccination program, because that is not being, the vaccines are not being made by government, But it's hard, again, to tell people that, because if people think that you're in on a conspiracy theory, they're going to think you're lying to them.
Exactly.
So I have found it really difficult to try and talk to people, to try and tackle some of these misconceptions. And one of the things that I'm really passionate about is opening up dialogues about science. And I make a real effort to be respectful to people's opinions. And sometimes I find that that's not always reciprocated from people who have, these really big conspiracy theories and that kind of stuff.
Yeah.
So it's an ongoing problem. And to be honest, we're not exactly sure how to dismantle that kind of thing.
Yeah, I think in general, our population, there's so many different, types of belief systems out there versus, let me actually rephrase that. I think because there's so many people in the world, there's so many opinions as well. So it's tough to really be able to have control and try and get everyone the same information, because, someone has access to this but doesn't have access to that. So I don't think we'll ever be able to fully grasp, fake, news and the reading of and actual publication of fake news, because, you can't really control it. So I think it's just something that needs to be looked at further, and somehow we can, even if it's 2% better, or if you change or give access to 2 people, that one Facebook post goes viral and millions see it. So it's, I think, something that we just need to tackle over time. And it's difficult. Sorry to interrupt. No, go for it.
It's difficult. We've also, with the way that society is kind of working now, and especially on social media, we have a lot of movements towards the treatment of people in an equal way, which and it's a big problem in the world. But part of that has, really been the encouragement that everyone has an opinion and everyone has a right to be heard, and that is true. But what is very dangerous is to ignore the concept of expert opinion. And I think that everyone should be able to voice concerns, voice their opinions, say what's going on in their minds. But I think that it's important to recognize when someone is dealing with it on a level of that this is what they do. I mean, it's kind of the same as if you get on a plane, you wouldn't go and tell the pilot how to fly it.
Exactly.
And you can have your opinion about, the pilot did a good job or didn't do a good job. But at the end of the day, the pilot knows more about flying the plane than you do. And it's kind of the same way, like, when it comes to speaking about the economic or the political effects of the pandemic, I will say this is my opinion, but I'm not a politician. I'm not an economist. I can't give an expert opinion on that kind of thing, and I think it's dangerous to be in a world where expert opinion is disregarded.
Yeah, I think that is also something that, and it's such a fickle thing, because social media has grown in its power, and its stance in the way that we live right now. Most people get their information because it is technically a free source of information. The cost of data is, based on where you are and Wi-Fi and all those kind of things. But the point is that it's free to access it. If you at an internet cafe or whatever, you can always go onto Twitter and follow the relevant news people. And I think that is where we are seeing, like you mentioned, the disregard for expert opinion, and why there's so much mistrust, because they think because it's on Twitter and these experts are also on Twitter, if I see a comment on Twitter, it means that it's valid because the experts are also on Twitter. So it's such a fickle thing to look at. With what you've seen over the past 2-3 months, once the vaccines in the US started being rolled out, I think it's been a month, close to 2 months now. What are some important facts that people should know about the COVID-19 vaccines, whether it be the Pfizer, Moderna? But for us, obviously, the AstraZeneca is more applicable, because that's what we will be receiving on the 1st of Feb with our healthcare workers. What are some of the important, scientific facts behind how the vaccine actually works?
Right. So before I talk about how the vaccines work, there are a couple of points that I want to just straight up stress. Firstly, the vaccines have been rigorously tested. The AstraZeneca trial globally had 24,000 people. The Pfizer trial globally had 44,000 people. The safety data that we have is robust, is statistically significant, and is trustworthy. Secondly, the vaccines do not have serious adverse effects. There's been a couple of people who had allergic reactions with the Pfizer vaccine, but those were people who had existing allergies to, strong medical allergies, and were found to have allergies to components of the vaccine as well. So it's important, just to disclose all known allergies before you have any medication, whether it's a vaccine or just a Panado. The third thing is the vaccine does not, no matter if it's the Johnson & Johnson and the Oxford and Sputnik models, or if it's the Pfizer and Moderna mRNA models, the vaccine does not interfere with your DNA at all. It does not change who you are as a person. It does not change what your kids are going to look like. It has nothing to do with your own DNA. And the final thing that I want to stress is that the vaccines only contain the information required to make the spike protein of the coronavirus, which is the protein we've chosen to teach your immune system how to fight. It does not have all of the genetic material required to create an entire coronavirus. So while you can feel some symptoms, like you can get a bit of headache, you can get a bit of body pain, joint pain from the vaccines, because you are tricking your body into thinking it's been infected, you cannot get coronavirus disease from the vaccines. So those are just 4 really important points that I want to stress. Oh, no, okay. So in terms of how the vaccines work, it's a really ingenious systems. So I'm going to speak about the Oxford and AstraZeneca vaccine now first. And this is the same model that the Sputnik vaccine uses and the Johnson & Johnson vaccine uses. So these vaccines are what we call replication incompetent viral vector vaccines. Now, what that means is we are using another virus called an adenovirus, which we've modified to be like the vehicle that delivers the genetic material of the coronavirus spike protein. So adenoviruses are viruses that cause the common cold in monkeys. And they're similar enough, like the systems in a chimpanzee and to humans are similar enough that the adenovirus can infect you. It can attach to your cells. But what we've done is we've modified it so that it can't replicate, it can't cause disease. And we've, in the adenovirus DNA, we've taken out the genes that code for the disease, that code for the virus replication, right? So it literally has just become a delivery system. Because what viruses do when they infect you is, if this is your cell, the virus comes and it attaches to your cell and it pushes its own genetic material, if it's DNA or RNA, into your cell, and it uses your own cell's machinery to reproduce itself, and then it gets released. So we've taken away that ability to reproduce, and we've just left it with the ability to attach to your cells and push in the DNA. So what we've done is in the coronavirus RNA that is inside the coronavirus cell, we've isolated the parts that controls the production of the spike proteins. So in biology, all proteins are made from RNA, from mRNA, and all mRNA is made from DNA. So we found the little piece of mRNA that codes for the spike protein. We took that out. We then synthesized another strand, so it became double-stranded DNA.
Okay.
And then we put that into the adenovirus. So the adenovirus is now as it is now, is a virus that can attach to your cells, cannot replicate, and will deliver the spike protein DNA. Okay. So it attaches to your cell, pushes in that spike protein DNA. That DNA gets turned into mRNA, and that mRNA now codes for the viral spike protein. Your cells then say, okay, here's some blueprints, let's make the protein. It makes the protein and then pushes it out of the cell back into the bloodstream. Your body then says, hey, there's something foreign in my blood. I don't know what that is. Let me go investigate. And it'll send your white blood cells, and it will pick up the spike protein as being foreign. So all the cells and all the molecules in your body that are part of you are labeled as being self. So anytime your immune system bumps into something that's not labeled as self, not labeled as you, it says, hey, I don't want this. Let me kill it. And your body will then pick up the spike protein that your own cells have produced thanks to the DNA, and it will then study the spike protein, develop antibodies, and tuck that memory away so that if you ever find it again through natural infection, you'll know what to do.
Yeah, it's actually, like you mentioned, it's quite an ingenious development, really, because, and I think also that's what's scary to many people is the idea when you listen to that. I mean, there is information on what you've just said, but I think because it's so hard to break down that it scares people to think, there's a lot of things going on here and I have to inject it into myself, and as soon as you hear, for instance, DNA, there comes the skepticism that, you guys are changing my DNA build, that my kids will no longer look what they were going to before I take the vaccine. So I think it's important to really, bite down on that knowledge and try and break it down to as simpler terms as possible, like what you just did right now. A question I have for you is, you mentioned that the AstraZeneca and the Johnson & Johnson have a similar build. Why is it that the AstraZeneca is 2 shots versus the Johnson & Johnson, which of now today is the 29th of Jan, hasn't been approved yet, but why are there 2 different ways of getting the vaccine out, 2 shots versus 1 shot?
So it's quite an interesting question, because both vaccines use the adenovirus vector. Both of them are fundamentally the same kind of design. What our trials in the AstraZeneca vaccine showed is that we get maximum immune response if we use a two-dose schedule where we give a half dose first to kind of prime the immune system, and then a second dose, which is a full dose, and then a month after that, we see that people have really high levels of neutralizing antibodies. What was found in the Johnson & Johnson trials, obviously I was not involved in those trials, but I've read a lot of papers that have come out of them. The Johnson & Johnson first dose does generally produce high enough levels of neutralizing antibodies to give protection. In the trial, they used 1-dose and 2-dose tests. And the 2-dose tests had almost double the amount of neutralizing antibodies. But they decided the evidence showed that the antibody titer, which is the term we use to measure antibody levels, the antibody titers from the 1-shot, the 1-dose schedule were high enough to give protection. However, it is likely that because there's so much evidence from the trial that shows you get more antibodies with the 2-dose schedule, it could be the kind of thing that a booster is offered. I think that in order to get the initial mass vaccination done, we can probably use a 1-dose schedule of the Johnson & Johnson because, if you're using 1 dose instead of 2, it means you can immunize double the number of people. And it also means that the traffic through your clinics is easier because people are not returning for a second dose. So you can come get the shot and never have to come back. So logistically, it does make a lot of sense to have a 1-dose vaccine. And this is my own speculation, is that with the Johnson & Johnson vaccine, you'll have your mass immunization with 1 dose to get your base level of protection. And I think once we have enough people immunized and the logistics become easier, I imagine that then they'll say you can come for a booster if you'd like, to really maximize the protection.
Yeah, I think especially based on our infrastructure and, just in general, our numbers, and just due to the fact that at the moment, hospitals are already on high alert. There's a lot of people in there for COVID. A 1-shot does make more sense, and it's just easier on our resources because we've already lost quite a few lives in the healthcare sector to COVID. So I think the Johnson & Johnson has, I think there was mentioning it's like 2 weeks away from being approved and also possibly produced here. So do you think that going forward would be ideally the mass vaccine for our population?
This is where it gets really difficult because there's a number of factors to weigh up. So the difference between the Johnson & Johnson and Oxford AstraZeneca vaccines and the Pfizer Moderna vaccines in terms of their structure is the Moderna and Pfizer vaccines use mRNA, and they don't have that protector. They don't have the adenovirus vector.
Okay.
So they just basically cut out the mRNA that codes the spike protein, put it in a little fat droplet, a little lipid droplet, and they basically just inject that, because your cells in your body have a fat membrane around them. So substances that are coated in fats can easily just pass through the membrane of your cells. So when they inject the mRNA in the fat molecules, it gets picked up by the cells in your blood and the epithelial cells around your blood vessels. And then the same process happens where the mRNA gets turned into the protein, which gets put into the blood, and you get an immune reaction. The difference is mRNA is a lot less stable than DNA, and the adenovirus that is used in the other vaccines will give protection because you're putting the DNA inside a shell, whereas the mRNA is not getting protection from the fat droplet. That's why the Pfizer and Moderna vaccines have to be kept at such radically low temperatures, right? Right up until the point that they're used, they can be defrosted. But they have to be stored at minus 20 to minus 80 degrees. Now, in a high-income country where you've got very robust infrastructure, you've got a lot of logistical support, that's easy. In sub-Saharan Africa, one of our biggest sources of vaccine wastage with vaccines that we use routinely is cold chain management failure. So cold chain management is the management it's as it says, it's the management of the cold chain. It's the management of the vaccine temperature from production through transport to delivery, maintenance of that temperature at the clinic before it's used. Because if your vaccines get hot, they fail, they stop working. Because remember, we're dealing with organic molecules. So all organic molecules fail at certain temperatures. So it's undoubtedly between the Johnson & Johnson and AstraZeneca vaccines, because infrastructurally they are much more stable. They don't have to be kept frozen. They can be kept at refrigerated temperatures of 2 to 8 degrees.
Okay.
That takes a lot of pressure off of our infrastructure and off of our logistical, the logistical pressure of it. I mean, for example, you could commandeer, this is really silly, but you could commandeer a Woolworths delivery truck that's refrigerated, and you could use that to transport the Oxford and Johnson & Johnson vaccines, which you couldn't do with a Pfizer or Moderna vaccine, right?
Yeah.
So immediately makes delivery much easier, makes cold chain management much easier. Here now is where decisions get difficult. You've got these two vaccine candidates. The Johnson & Johnson vaccine, when I last checked, I think is $10 per dose, and it's one dose. The Oxford vaccine is $3 per dose and is 2 doses. So you're still paying $4 less per person than the Johnson & Johnson vaccine. So economically, that's 1 point for Oxford AstraZeneca. Now let's talk logistically, traffic through our clinics. We already struggle with the infrastructure that our healthcare system has.
Yeah.
I mean, even outside of a pandemic, in normal life, it's crazy. Government clinics get packed, especially when you're talking about for the first 2 months of lockdown, I was volunteering. I was working at the Alexandra Community Healthcare Center, helping in casualty and doing COVID testing and screening. And, I really commend the nurses and doctors who are doing the job they do, because I'm going to be very frank, they don't have a lot that they're doing it with.
Yeah.
So if you can say, I'm effectively going to half the number of people coming through the clinic by only having to give a person the injection once, that's a huge pro for the Johnson & Johnson vaccine. Now one has to decide and this, when I say one, I mean the government has to decide, is that $4 per person worth worth it if you are now going to have to deal with all this traffic through our clinics. So it's a very difficult decision to make. What I would like to see personally is a combinational approach where we have both vaccines. I think that in our very dense urban areas where we've got government clinics under a lot of strain all the time, I think it makes sense to employ the one dose Johnson & Johnson. And then I think in more kind of rural areas or in the private sector, I think it makes sense to use the Oxford vaccine, where it's a little bit easier to manage returning patients because the proportion of the population that you're serving is less. So I think that would probably be the most sensible approach. It also depends on how the government are going to roll out the phases that they've said they're going to do it in. So we know phase 1 is going to be healthcare workers. That's pretty straightforward because they're at the clinics anyway. Phase 2 is going to be your essential workers and high-risk individuals. And as you go down these phases, the number of people in each tier becomes bigger and bigger. So when it gets to the point that they say, okay, now we're going to start vaccinating general population, we've done our healthcare workers, we've done essential workers, we've done high-risk people, are they going to stratify that further and say, okay, from this month to this month, people with this surname can go? I don't know. I'm speculating completely, but I mean, because there's going to be many, many millions of people, and they can't all just rock up at once to a hospital and say, I want the vaccine. So that the government has a lot to think about there. Has a lot to think about for sure.
And we going back a little bit to. There's a few rather intense theories out there that, do the rounds on WhatsApp messages and Facebook posts that, and even on TikTok. I've actually seen quite a lot of this on TikTok. There was a small clip of a woman, what it seems like was from the World Health Organization, and it was a very short snippet of a conversation about, how well Africa is as a testing ground along those lines. You obviously are quite well informed and qualified in this sector to maybe explain to us why there is a need to test medicine in various regions, specifically because of what you mentioned earlier, that some things will work really well in Europe, come down to sub-Saharan Africa that might not be as effective. Because there's this huge, and it's also a valid perception that Africa is used as a testing ground for medicine, and then from Africa, once it's deemed safe, you can then test like West and East and the Eastern world. So can you maybe just take us through the reasoning why it's important to have trials in Africa and as well as in other parts of the world?
Yeah, for sure. It's a very relevant question, and there is a lot of concern, coming back. The world. Yes, we live in a world that is ostensibly equal now, on paper at least. We've seen a lot of problems with continued prejudice and racism and unequal treatment of different people. But the world was colonial very not long ago. And it was like unfair treatment of people of color, and open racism was common, a stone's throw back in terms of history. And I think that there was I think that there is a lot of fear that a trend has been set in the medical world where like Africans can just be used as guinea pigs. But what I really want to stress is that that's not the case. And as I kind of was mentioning earlier, there's a lot of medications that we see working very well in one region and not very well in another. And for this AstraZeneca trial, for example, our 3 main trial centers were England, South Africa, and Brazil. So we had 3 very diverse population groups that we were looking at. And yes, trials get run in Africa, but it's not before they get run in the West. It's often at the same time as they're being run in the West. And in fact, a huge problem is that sometimes medications get released here where trials haven't been run here. They've only been run in the West. And there isn't data to show how well that thing's going to work in this population. And it kind of goes back to what I was saying earlier, yes, we're all people. Yes, from a sociological, socio-political point of view, there is no difference between one person and the next. But genetically, there are different versions of genes. And when you have a population that has lived on the southern tip of Africa for thousands and thousands of years, and you've had a population that's lived in the northern tip of Europe for thousands and thousands of years, there are different, if there are different versions of the same gene in those 2 populations, they will be propagated through inbreeding in that population, and you'll get a version of the gene that exists in this population that doesn't exist in that population. Now, like I said, everyone has the gene that controls eyes. Everyone has eyes. But why do Swedish people have blue eyes more commonly, and why do Zulu people have brown eyes more commonly? And that's not to say one eye is better than another eye. It's just to say those eyes are different, right? And it's the same way with genes in your immune system. There are very important proteins that control immune reactions, and we call these proteins HLAs, which stands for human leukocyte antigen, but that's extra. But there are literally thousands and thousands of different variations of the same HLA genes. And you get variations that exist in Southern African populations that do not exist in Far East Asian populations, and you get variations there that you don't see in South America. And, there are all these bubbles all over where you have genetic diversity between different populations, right? And it is really important when you're testing groundbreaking medication and vaccines to make sure that the product you've developed is going to work with these subtle differences in the way that the immune system is working across the world. So, for example, my main research is in rotavirus. And the rotavirus vaccine that I mentioned earlier that works really well in Europe and doesn't really work so well here, part of the reason that we're finding evidence for that is because the genes that control your blood groups, so the rotavirus vaccine uses little proteins on your blood cells, your red blood cells, as the thing that they attach to infect you. Now, everyone knows that you have your A, B, and O blood groups. But in that gene, that one gene, the ABO gene, there are 240 different versions of that gene, right? And there are versions of that gene that exist in Southern Africa that do not exist in Europe, and vice versa.
Yeah.
And we are finding that there's a lot of genetic diversity between sub-Saharan Africans' blood group genetics and European blood group genetics, and that could affect the way the vaccine's working, right? And that's why it's so important that we have varied testing locations, that we make sure that our testing locations are including lots of different populations from lots of different origins, and there is absolutely no preferential treatment in how populations are selected, in how they're treated, in how the trials are run. In fact, it's incredibly important for the validity of the data that the trial is run exactly the same everywhere. The way the trial was run for the AstraZeneca vaccine in England, in South Africa, and in Brazil were identical. We had the same set of instructions, right? And, I just really want to make people feel safe that no one is used as a guinea pig. It doesn't matter who you are, what you are, where you're from. We use a variety of different people from different populations in all clinical trials. It's never targeted.
And This also brings me to the next question is, the general reception to the vaccine, and it's not to say just in South Africa, but worldwide, is very skeptical in general. And I think one of the main things is also based on what you said earlier was the turnaround time and people having the perception that a vaccine takes 5 years to produce and then push out to the public. So how do we, and you as a person in vaccinology, ensure that, or what can you say, people should do? Where should they read the information? How do we ensure that people are consuming the right information? And I suppose, are you shocked by the way the vaccine has been received worldwide as well?
No, I'm not. And it's unfortunate. I wish I was.
Yeah.
But, since 1998, the anti-vax movement has been growing steadily. I think it was 1998 or 1988, I can't remember which one. I think it was 98. There was a disgraced physician and scientist whose name was Andrew Wakefield, who published that infamous, MMR vaccine causes autism paper. Now, that paper has since been taken down. He did the most unethical thing, which was he decided on a conclusion and he made up evidence to support it. He said, I want to say that the MMR vaccine causes autism. He then conducted a trial which was which used very bad scientific principles, which used very unethical principles, and he fabricated evidence to support his outcome, right? And there is and one of the most important things in scientific discovery is for results to be replicated. Another lab, you can publish something, but in order for that to be accepted, a number of other labs around the world independently, with no input from you, have to be able to reproduce your results. And no one has ever reproduced the results that vaccines cause autism. It's not true. And the damage was done, unfortunately.
Yeah.
And the movements gained momentum. Andrew Wakefield was struck off the medical roll. He was disgraced. He was disavowed as a scientist, as a doctor. But to this day, he still campaigns anti-vax. He still does public speaking. And people attend and listen. And the movement has gained huge popularity. And, as I said, people are entitled to their opinions. It is a free world. No one is going to mandate the vaccine. No one is going to say you have to take it. Private institutions can have a policy where they require you to have the vaccines, but that's a private thing. It's not a government thing. But at the end of the day, I would like people to have an informed decision. If you have considered evidence and you have arrived at your conclusion, if your decision is considered, I will respect it no matter what. If you've read and listened to the evidence that supports vaccines and you genuinely say, after hearing that, I am just deciding that I still would not like to be vaccinated, I respect that. It's fine. The thing that I have an issue with is people who are kind of blindly against something. And they don't make an effort to understand before they cast this very judgmental view. And, it's so difficult to tell people where to go and get information because, and this is exactly what we were speaking about right at the beginning of this episode is the good information is written in the super technical language.
Yeah.
And it's really hard to find people who can reliably translate it, for want of a better word, into kind of simple English and put it out. And, the problem is, and yes, public platforms like Twitter have started instituting fact-checking and that kind of stuff. But, you know, the problem is that the internet is free to use and unmoderated. It's unregulated. I can go and post whatever I want on the internet, right? And I can, as a scientist who's got no, I mean, okay, for example, I know absolutely nothing about art, okay? But I can go and post the most controversial opinions about art freely. And who's going to do anything about it, right? And someone might read my opinion and say, hey, I'm going to use this opinion. They don't know that I know absolutely nothing about art. They've just read an opinion that I've published, right? And that's the big issue. I would say to people, use social media platforms to reach out. You know, don't be afraid to ask questions. And I actually put up a Facebook status the other day saying, no matter how stupid people think you are, or say your opinion is, or say your question is, you always have the right to ask it. And you are allowed to be concerned about what is going to be put in your body. That is a perfectly legitimate concern. And I, as a vaccinologist, do not expect you to just blindly accept it. I want you to support it, and I want you to take it. But I also would like to help you understand why. You know, why does it work, and why is it important that you have it? So, you know, my socials are, you know, we can put up a little thing with my socials.
Yeah, for sure.
You know, anyone can contact me at any time. I will do my best to help. But, you know, if you have read a couple of things, I would say try and diversify the sources. You know, you can read mainstream news. You can try and read a few scientific magazine articles. If you want to attempt a journal paper, you can try tackle it. The biggest thing I'd say is don't use one source. Use a variety of sources. Make sure that you're looking at a variety of different opinions. And fundamentally, at the end of the day, if you don't know something, find someone to ask. Part of the wonder of social media is not only can you say whatever you want or read whatever you want, but you can also talk to whoever you want.
Exactly.
And use your network. Try and find someone who's willing to talk to you about this kind of stuff, who does have a background in it. There are a lot of people like myself who are very, very happy to engage in conversation, who will do it respectfully, who will try and talk to you about what you're concerned about and try and make you feel better about it. And like I said, you know, I'm not going to belittle someone who's an anti-vaxxer. They're allowed to believe what they want to believe. They're allowed to feel the way they want to feel. If that's the direction you want to go in, I respect you. If anyone would like to have a constructive conversation where they genuinely would like questions answered, then I will always have that conversation 24 hours a day.
And that's actually how I ended up reaching out to you, was seeing that post, because and it's something I've seen in general, and it's not only in your field but the public as well. So I put out a Instagram poll on my Instagram stories asking people would they take the vaccine, yes or no. And then I further asked, you know, are they skeptical of the vaccine? So what I found was that there was obviously a fairly big split. I would say there's a majority on yes, I'll take the vaccine. About 67% said yes, and the rest said no. But the amount of people who saw that poll and didn't answer was much greater than the actual sum of the people that did answer. So that just shows you in general, like, people are firstly afraid of being judged. I think that's also one of the main things, is like, oh, because I can see who's answered yes or no. And I think that's also one of the things that people are just afraid of, not knowing and then being judged for not knowing what people deem to be, you know, common or general knowledge per se. So I think it's such a scary time for everyone, because we don't really, as general public, we don't have the answers, and we're scared. You know, people are scared to ask, and it's something that we need to kind of break down, that barrier of being afraid to ask questions that concern us. Like you mentioned, we need to be reaffirmed in our decision by the knowledge being given to us. So if you can tell us why the vaccine is good and why we need to be taking it, it gives us a reason to say, okay, I'll take the vaccine. But it can't just be that blind association to science, like, oh, science is always right. And I think
Exactly.
the government are working on that right now. There's a huge campaign underway trying to, just educate people further into, what the vaccine is going to do for us as a population and how it's going to help us, move forward, from COVID-19. So I guess that makes me want to ask you, are you as a vaccinologist slightly disappointed that, with our heavy involvement of the trial, with the AstraZeneca trial, that we haven't been vaccinating already? Or do you think there's just way more at hand with that, with logistics, money, that kind of thing?
Yeah, unfortunately, that boils down to politicians and financing and that kind of stuff. It would be fantastic if they said, hey, look, you were fundamental in our trials, so we're gonna, just give you doses and make sure that you top of the queue. But unfortunately, it's not how it's working. And there are really amazing initiatives like COVAX and the African Vaccine Procurement Initiative. But ultimately, those are firmly within the realm of politics. I'm not really. I don't think I'm really in a position to comment on like the political movements and how the government is spending money, because quite frankly, I don't know. I just that's their thing. What, as a vaccinologist, is upsetting is the possibility of getting to a point where there's such a discrepancy between high-income countries and low-middle-income countries in terms of the vaccination schedules, where, I think it would be a travesty if America, for example, was vaccinating healthy teenagers when we still had doctors in ICU not having had vaccinations. This opens up so many questions about global conscience and justice and equality and equity, and should like what kind of should high income countries take it upon themselves to say, we've got our essential people vaccinated, now we must help low middle income countries, or are they going to say, well, that's their problem? That's that kind of thing. And there's a lot of cogs in this machine, and there's a lot of points at which I think it could go wrong. One thing I do want to say is, yes, governments have let people down before, and corruption is a big deal. But specifically with coronavirus, I would like to commend the South African government and Cyril for the response they've had and the effort that's being made. You mentioned the education campaign. The information they're putting out is really good, reliable. They've tried to make it as accessible and in terms of language and sort of platforms as possible. And I genuinely think that Cyril is one of the best global leaders in terms of his response to this pandemic. The speech that he gave on the 28th of December, I think was one of the best speeches I've heard any world leader make in this pandemic. And I can guarantee you that if we had, as a nation, if we had the resources that, for example, Trump had access to during his presidency, we would be in a much better position with the leadership that we've had. So, the South African government has its faults and has made mistakes, but I think in this regard, I take my hat off to them.
And, with you studying, certain demographics and certain populations, given how we've, as a country, the way COVID has spread, what's your take on, do you think that based on our general, you mentioned the anti-vax movement, but South Africa is also quite strong in the way we vaccinate from a young age. Do you think that has also been a contributing factor to, I mean, there's a lot of people who have lost their lives, but also there have been quite a few recoveries. I think the percentage is 88% at I think as of yesterday. Do you think that structure that we've had, especially for people kind of my age and a generation or two behind, have kind of built a strong not immunity, but we have a strong immune system in a sense because we've been vaccinated and have some form of antibodies that can kind of fight through certain illnesses?
Yeah.
Viruses.
I think that generally we have a population that is very compliant with medical procedures, and we have a very rigorous vaccination schedule, and we have very good vaccine coverage, and one thing that's been speculated is with TB being such a big issue in Africa and not in Europe and America, we still take the BCG vaccine, which is the TB vaccine we currently use, and there's been some evidence saying that maybe the BCG vaccine has given some kind of immunity. But yeah, I think that having a population that's generally compliant with medical science is really helpful. I think that for the most part, the South African population will get behind the vaccine, and I also, generally, with the exception of a few hotspots, with the exception of a few sort of subsets of the population, the lockdown rules have been really well listened to. What we call non-medicinal interventions, so the mask wearing, the hand sanitizing, the social distancing, I think that is generally the response has been very positive from our population. There are, like I said, a few hotspots, areas where there have been some issues. Definitely not looking at Cape Town. But no, I'm just kidding. But yeah, it does help for sure. And, I think, for the most part, we do have fairly strong we do have fairly strong immune systems in our population.
Yeah.
But on the other hand, we also have a lot of big problems, like we have a very big HIV epidemic. We have a very big TB epidemic. And, those kind of things can then significantly introduce weaknesses when it comes to infections like this. But for the most part, I really am confident that when the vaccine gets rolled out here, I think that a high proportion of our population will take it. And what's really important, and as you mentioned that poll you did on your Instagram, and like I said, people can choose not to take the vaccine. It's their individual decision. But what I would like to make people aware of is the potential consequence of not taking the vaccine. Because we vaccinate not only to protect an individual, but to protect the community. There is no such thing as a vaccine that has a 100% efficacy, right? Say we have a vaccine that has a 80% efficacy, right? If we vaccinated 100% of the population, then 80% would be protected.
Yeah.
Okay. So there's been this term thrown around called herd immunity, right? And what herd immunity means is if you have someone who is not protected, so say they either have not been vaccinated or they were vaccinated but they didn't have immune response, we call it seroconversion, when someone develops protection from a vaccine. So if someone has the vaccine and does not seroconvert, the idea is if they're here and they're surrounded by people who are protected, the virus has no way to get to that person because it can't be transmitted through that safety bubble, right?
Yeah.
So that person is protected through the herd, protected through the community. Now, if we have, for example, the Oxford AstraZeneca vaccine has a efficacy of roughly 70%, right? We need to immunize as many people as possible to achieve that high immunization threshold that will give us herd immunity. And also, herd immunity will only work if out of our whole population, the people who are not protected are kind of spread out. If you have multiple people who are unprotected together, the virus cancel travel between them. But if every person who's not protected is buffered by people who are, then they're protected by proxy. So what I think is important to stress to anyone who is considering not taking the vaccine is I would just want you to consider other people as well. Consider your community, your next door neighbor, the other kids in your kid's school. And this is a big problem we have with the anti-vaxxing parents is, you can have a child who's not been immunized and they can go to a school. And even though all the other kids in the school have had their shots, not every single child will have seroconverted. Not every single child will have protection. And that one child that is coming in with no vaccines can bring in measles, and then kids who are vulnerable can get it, and what we beg you to think about is other people around you. This is a team effort. It's not an individual race. I just, if you have thought about it and you understand it and you're okay with the potential consequence of not being vaccinated, okay, there's nothing we can do about that. But if you haven't considered that, then maybe it's something to think about.
Yeah, and that brings, so many. I think this pandemic that we find ourselves in is really to kind of emphasize empathy in general, because it is of such contagious values, so it's things that we are so commonly used to now we can't do. And for the people who didn't obey or kind of follow the protocol, that lack of empathy then results in death, unfortunately, which is sad. But it just shows what we lack in a community and what we also strive in as well. So it's kind of just showing weakness and strength at the same time. A question I have for you is, I mentioned earlier that a couple of years ago, we've seen a lot of documentaries on pandemics and, when will the next pandemic hit? And then, coincidentally, 2 years later, we find ourselves in COVID-19. And Bill Gates has been at the forefront of many of these conversations. And he, I think just because of his persona and his, financial power, is often associated with, this conspiracy that, these things, why is it that 2 years ago he said there's another pandemic coming, and within a 2-year space he's busy telling us, look, I told you so. And there's so many questions. You being in vaccinology, you obviously have a certain grasp of the way these things work. Do you think, and he's mentioned Bill Gates, I think it was recently, where he said that there will be more pandemics in the future. Can you explain how do we as a general public move forward knowing that these are possible things coming through? Is it the development in the medical field that needs to be more intense, or do you think it's the government that also needs to start prepping for another pandemic that may hit in 20 years time, but it's the infrastructure we could build to then, for instance, by that time have more efficient lockdowns for longer periods to ensure that we don't spread the virus, in a sense, because we'll then have been prepared financially to support our population, like what New Zealand and Australia have done, versus what we had to kind of on and off because we just can't afford to be closed for as long as they have.
Look, I think it's a pretty good, it's an excellent point. And, these ideas that Bill Gates wants to put chips in you, and you know, like what, you know, the idea that he manufactured these things to make more money, and you know, they really are just ludicrous. I have worked with the Bill and Melinda Gates Foundation. My current master's research is actually funded by the Bill and Melinda Gates Foundation, and you know, without their involvement in global health, we would be a lot further back than we currently are. We have a lot to thank to Bill Gates and his wife Melinda. The reality is, you know, I was chatting with a guy who's very senior in the Bill and Melinda Gates Foundation. He's the head of their enteric vaccines unit, and he was saying, you know, Bill Gates, you know, finds these ideas that he wants to make more money quite funny, because he says he has enough money. He doesn't need more money. And he's actually trying to use the money he has to fund things. He's not keeping it for himself, you know. I wish that guys like what's his name? Jeff Bezos, the Amazon guy.
Bezos.
You know, I wish that I wish he would take a leaf out of Bill Gates' book and do something with his $123 billion that he's sitting on. I mean, I also did you hear that thing? You know, when Elon Musk said he wanted to create this interface, and he said he literally wants to surgically implant a chip in your brain, right? And everyone, I mean, it was like Bill Gates was like, let's fund this vaccine. And everyone's like, oh my God, no, he's going to put a chip in your brain. Elon Musk says, I literally want to cut your head open and put something on your brain. And everyone's like, what a great idea, you know? I mean, it's bizarre. It's bizarre. Where do these things come from? And listen, I can assure you, and I know that people are going to say, oh, but you're funded by the Bill and Melinda Foundation. You're in on it, you know? And but the Bill and Melinda Gates Foundation does incredible work with public health, vaccine development, water purification, housing, education. I mean, they spend upwards of $4 billion a year per year on initiatives around the world.
Yeah.
I mean, that is incredible. And, you know, Bill Gates, yes, 2 years ago he was saying there's going to be another pandemic. But it wasn't just him saying it. There's been a lot of evidence, you know. 10 years ago, a paper was written by Chinese scientists saying we need to regulate the way our food markets work because they're a huge hotspot of disease spread. You know, something's going to happen. And a lot of, you know, that you get people who are virologists, bacteriologists, epidemiologists who are constantly monitoring disease statistics, constantly monitoring the way viruses are changing and evolving. And we can see that these are trends. And like I said, you will never, ever get rid of viruses completely. You'll never get rid of pathogens. As our population globally grows and we live in an increasingly densely populated world, you know, we are bound to have new diseases popping up. And just like how every animal and organism on Earth has evolved to survive the best it can, viruses do the same thing. Yeah. And, you know, Ebola did it in 2018. You know, we had swine flu, we had bird flu, you know, and these things will continue to come up. And no one is making them. No one is benefiting from having a global shutdown. No one is benefiting from having people die. Believe it or not, you know, we actually want as many people operating in our economy as possible. We want our economy to be as free-flowing as possible, especially, like you said, in a country like South Africa, where we don't have the resources of a New Zealand or in Australia or in America. You know, we are suffering hugely by having to deal with this pandemic. And there is no way that we can prevent further viruses, further pathogens from coming up. But what we can do is increase our education on how we live in a more healthy way. We can increase our education on the basic science behind not only medicine and how treatments work, but also behind vaccines. And what I think, you said is the answer to put more development into medicine.
Yeah.
Look, our treatments are good, When people can get to hospital and there's available care, it's generally very good. But what would be even better is trying to prevent people from having to go to hospital in the first place. More development does not need to go into therapeutic medicine. It needs to go into preventative medicine. We need to be putting more resources, more people, more effort into increased vaccine discovery, production. We need to optimize processes. We need to aim for a system where we don't want to have to respond to more sick people. We want to try and get less sick people in the first place. And like I said, we're not going to do that by preventing the viruses. We're going to do that by optimizing our response to it.
Yeah, definitely. I think that, and especially, for us, with that initial lockdown, that was kind of our time to prepare. That's what the whole idea of that hard lockdown was, to prepare our healthcare system to manage, because obviously we knew the way we operate in our population that there would be quite a few waves and quite a surge of people coming through our hospitals. So I think it's definitely an eye opener for many fields to be prepared for something of this magnitude, whether it be 40 years from now. The fact is that 40 years from now, there'll be another population going through it. So we need to be as well prepared as possible.
And what people also don't realize, you just hit the nail on the head. You said there'll be another population going through it.
Yeah.
And, even though pandemics are pretty rare, there are epidemics happening all over the world all the time.
Yeah.
There are pockets of disease that are ravaging populations all the time. Even though we dealt with the Ebola crisis in 2018, there is still in Central and Eastern and Western Africa, there is still a huge Ebola problem. Measles, currently, the US is having a huge measles epidemic. And we can't only have this kind of response when it's a huge global issue, like these huge, I said to someone the other day, where was this global panic and where was this concern when Western Africa was being destroyed by Ebola in 2018? And why is it that high-income countries have to be directly affected before they step in and want to offer their resources?
Yeah, 100%.
And we need to change that, and we need to get more assistance, and but we can't just wait for the crisis to actually be in full-blown form before we react. We have to be preemptive about this kind of stuff.
Yeah, I agree. I think, and also it shows that, because like you mentioned, there has been a lot of talk about a pandemic hitting, for a long time now. And the fact is that when it came, we weren't ready. And it wasn't just like South Africa, it was the world. The first world countries struggled to adapt. And they find themselves struggling now to this day. And in some ways, worse than what we are, in a sense that the numbers are so great there. And almost that they've taken their healthcare systems for granted, because they're like, oh, we have the infrastructure. We don't have to be as, strict. And now you can see the numbers that are in the US and even in the UK. It's quite sad, that, and it comes back to the leadership and the lack of leadership that's been found, through this time. There's been a few reports over the past few days that the AstraZeneca vaccine for people over the age of 55, they're saying that on the second shot, the efficacy goes down. Apparently, there's these, obviously AstraZeneca came out and said that, that's not true. But a question I have for you is, where do these things come from? Because it's almost like the people that aren't involved with these things are coming up with these reports.
Listen, I have no idea where that comes from.
Yeah.
The immune system is a very dynamic process. In newborn babies, it's very bad, and then it gets really strong, and for most adults, it's pretty strong. And then in the elderly population, the immune system starts weakening again.
Yeah.
And it's been a notorious problem with vaccines that it's very hard to stimulate a good immune response in elderly people because their immune systems are kind of starting to weaken. And that's one thing that made the AstraZeneca Oxford vaccine so cool and so good, is that we had a 70% efficacy as opposed to a 90% efficacy from Moderna, but we had really consistently good immune reactions across all age groups, including elderly people. We have, so the ability of a vaccine to cause an immune response is called the immunogenicity of the vaccine, right? And the ability of a vaccine to cause side effects is called the reactogenicity of the vaccine. The Oxford vaccine has very high immunogenicity in all age groups with very low reactogenicity. So it's kind of like it's a textbook vaccine. It's the kind of figures you want. I would strongly recommend that all people above the age of 65 still go get the vaccine. It will still give you protection. Our data from the 24,000 global participants in our trial has showed that our immune reaction data is very stable across all age groups.
Has the introduction of this, they want to call it the South African variant, which is also found in the UK, and they're very happy to label it the SA variant. How have you kind of looked at this? Obviously, these things are common, the mutation of viruses and so forth. Has it worried you, and also kind of put a bit more urgency in the way you would want us to be vaccinated as soon as possible?
I'm just going to reiterate a point that Professor Abdul Salim Karim made. We really don't like geographically labeling these variants. So the variant that everyone is now calling the South African variant is the 501 V2 variant. And the reason we don't like saying, it's the South African variant or it's the UK variant or whatever, is because just because that's where the variant was identified, it doesn't mean that that's necessarily where it originated. And what happens when you start saying this is a UK variant or this is a South African variant is people start then having prejudice against those populations because it becomes like a blame game, right? And we want to avoid that. It's not this geographical region's fault that the virus mutated. That's just what viruses do. And it's got nothing to do with the response of that nation. It's just, like I said, it's just an evolutionary process and it's what virants do. So with this 501v2 variant, there is concern about what impact it will have on the vaccine efficacy. Data has just been released that the Novavax vaccine, which is an American company, they also had clinical trials in South Africa. The Novavax vaccine has shown to be unaffected in terms of its efficacy and protects against the new variant as effectively. Data for the other vaccine candidates with regards to their response to the new variant is still being gathered. So I'm unable to comment officially, but in terms of my opinion, I believe that there's still a very good chance that the vaccines will work effectively. So if you have, I'm going to use my glasses case as an example of this is the coronavirus spike protein, right? Now, at the top on either side is where the protein actually attaches to your cell, right? Now, when we give the vaccine, we're giving your body basically the whole protein, not just those two places, okay? So when your body studies this kind of thing and develops antibodies, it doesn't only make antibodies against one spot. Antibodies start recognizing positions all over the protein, okay? Now, when there's a mutation, obviously one of those spots will change.
Yeah.
So one of the mutations is in this binding region. So the antibodies that your body had made that recognize that specific position may not recognize the new version of it. But you still have so many antibodies that can recognize all the other conserved regions of the protein that are unchanged, right? Now, there are different ways that an antibody can neutralize a invader, a pathogen. The best and most effective way is if an antibody comes and binds to that spot, then the virus is physically unable to attach to your cell because that space is occupied, right? It's kind of like if I go, it's exactly the same as parking in a parking space. No one else can park there now, right? Now, if that parking space is now no longer available because the antibody doesn't recognize it, there's a chance that the antibody that comes and parks in this next door parking space can park so badly that you can't get into that parking space anymore, right? Like, how often have you seen someone who's just parked so close to the damn line that you can't get your car in, right?
Exactly.
So that's kind of the hope, that the other antibodies that we have will do a good enough job of interfering with the protein that it won't be able to do its job. But antibody responses are just one component of our immune system, and there's a lot of other factors that can contribute to your protection. So in my opinion, I think I'm very confident that there are enough other sites on the protein for antibodies to attach to, and there are enough other components of your immune system that there will still be effective immunity. I know that there is, there's been a big thing about the antibodies people gain from natural infection, not seeming to not be that effective with being infected with the new variant. But what I also want to point out there is that there's a big difference between natural infection reactions and stimulated infection reactions. So the way that, with one of the advantages of a vaccine is that we can really design and target the kind of immune response we want. We can make it way stronger. And when someone is infected naturally, it's kind of a bit of chance involved in how strong their immune reaction is. Also, with respiratory viruses generally, they're not well known for establishing very good immunity through natural infection. Something like measles, if you survive natural infection, then you can have lifelong protection. But part of the reason that you can get the flu every year is respiratory viruses are not very, our body is not very good at retaining memory from them. So there is a bunch of issues with naturally obtained immunity that can be overcome with the vaccine. So that's why I also say if you've had COVID, still get vaccinated.
Yeah. And also, I think what people also tend to forget is even if you are infected with COVID and even if you are asymptomatic and show no symptoms, there are a lot of research that's being published on a regular basis that shows that there is still possibly a long-term effect that you may not know of right now, but there may be something that could be wrong come down the line. So you just don't take the chance, really, because that was
Yeah.
the main thing. Was like people had this idea that, oh, I should just go and get COVID and I'll be fine, but and because I'm young,
And
I should be fine. But now the
yeah,
the new variant is also showing more. It affects
the
more of the
younger
younger
population.
population, and I think that's what people are
Yeah.
starting to kind of forget, is that this isn't just COVID-19 now. There's another piece that we need to kind of be more careful about.
Yeah, there's 2 points that I want to make on that. And the first is, there's actually 3 points I want to make on that. The first is that a lot of people forget that if you're asymptomatic, you can still be infectious,
Yeah.
right? Even if you have no symptoms, you can still pass on the virus. The second thing is this whole idea of, I'm young and I'm perfectly healthy, I don't have any comorbidities, I'll be fine. The reality is you can't take that chance.
Yeah.
I have seen an 88-year-old guy who got COVID, had a slight little cough and was fine. And I saw a 27-year-old person who used to run marathons and was ultra fit die, and you can't take the chance. And especially with the new variant, we're seeing a lot more young people being infected, and just don't take the risk. And the final point is, people are so hung up on the mortality rate, on the death rate. And they say, people are so scared of COVID, but flu kills more people, TB kills more people, HIV kills more people. Yes, we have more high mortality viruses and more high mortality infections. But the reality is that it's not about how many people are dying with COVID. It's about how many people are getting sick with COVID.
Yeah.
So the death rate is called the mortality rate, and the sickness rate is called the morbidity rate. Now, if you take let's take a casualty at a hospital. Typically, your casualty will be divided into your traumas, your car accidents, stabbings, gunshots. You'll have a little bit of TB, a little bit of HIV. You'll have your heart attacks, your strokes, that kind of thing. Now, your casualty is COVID. And there's no space for your traumas. There's no space for your HIVs, your TBs, your heart attacks. The problem with COVID is not that it's killing more people than HIV or TB.
Yeah.
It's that it's making so many more people sick at once. This is the first time we've had a virus that is so good at making so many people sick at any one time. And that's the problem. That's why it's shutting us down. So to all the people who say, well done to everyone who recovered from a virus with a 98% survival rate, or, it's like all of that. It's not about that. It's not about the fact that this virus is going to wipe out human populations, because that's not going to happen. It's the fact that this virus can have such a huge percentage of our population man down with sickness at one point in time. And I want people to stop talking about the death rate, because that's not what's important. It's the morbidity rate, the infection rate. That's what's serious.
Yeah, and it's going to carry on getting scarier once we see the long-term effects of COVID, because now I follow quite a few people in the US just in my field of, photography and video, and I've seen quite a few people who are now involved in studies for they call it long COVID or something along those lines, where it's the long-term effects of having COVID. So they may have recovered and they're no longer infectious, that's all past, but they struggle to breathe. They can't do, they can't really exercise anymore because of they can't really breathe when under stress, when their lungs are under stress. And there's just so many things that are now you can't really know all of these things, a year ago. So there's things that are coming to the forefront right now that will then hopefully open people's eyes to the seriousness of what this is doing to us.
Yeah, no, I agree with you completely. And the reality is that it's gonna take years of research to understand exactly what the ramifications of getting this virus will be. And And, it is, it's incredible that, even 6-7 months into this, that we had such a good understanding of the virus. Because, in terms of understanding a new disease, a year is nothing, right? We have been studying HIV and AIDS for 30 years. No, 40 years almost. We've been studying this. And we still don't fully understand a lot of the dynamics, right? Cancer, we still don't understand the dynamics properly. So the fact that the scientific community has got this robust of an understanding of COVID after a year, well, it's 13 months now, is truly phenomenal, really.
Yeah.
And it is going to take a very long time. And the problem is that the morphology of the disease, the range of symptoms is huge. You can have, I've got family friends where the husband and wife have both had COVID at the same time. So they both had exactly the same virus and both had completely different sets of symptoms, right? And I've got a friend who had COVID and then was down with pneumonia for 5.5 months.
Jeez.
And it's tough, man. And there definitely, we have seen people who seem to have been long-term damaged by the infection. That's going to take a long time and a lot of effort to characterize and understand. But it is another reason why this shouldn't be taken lightly. And I understand and I fully support the fact that a person's well-being is more than just their physical health.
Yeah.
You also have to look after your mental health, and isolation and quarantine is psychologically unhealthy for us. And yes, you do need to maintain your social life. You do need to see people. There's all those basic human needs that need to be met, but they can be done responsibly.
Yeah.
And when I see, before alcohol was banned again, I would see bars that were packed with no masks, no social distancing, like people even sharing around like a hookah, like a hubbly bubbly. And that kind of thing, I think is just so blatantly irresponsible, because, those are a lot of people who either have the attitude of, I'm young, I'll be fine, or a lot of them could be COVID denialists or kind of say the whole thing is too, like we're worrying too much. And as soon as those people then experience, as soon as it's their grandmother or grandfather or mom or dad or whatever, then they suddenly say, oh my word, this thing is serious and it's real, But yeah, I'm not saying that you should put yourself in a hole and never see another human being. I'm just saying find a way to socialize responsibly and maintain your social distancing, maintain your sanitizing, your face masks. And at the end of the day, the only way that we can beat this thing is together.
Yeah, I think that's the main thing that people are sort of looking past, is that, it's not to single out anyone in any way. It's just that because this is such a social virus, that we need everyone to kind of be on board with the same, outset, like this is what we need to do as a community, as a country, as, the general population of planet Earth, really, that we just need to be within one frame of mind that this is the ultimate goal. Just wear a mask and social distance. It's not that hard. And I think, like you mentioned, the mental health side does contribute a lot to, the general feeling towards this period of time. But like you mentioned, there is a responsible way to do things. And I think that's what, if people can just keep that in mind, we'll get through it eventually. Like you mentioned, it is going to take a long time, and we are quite impatient, quite an impatient species. So we just need to look past the urgency of wanting to go back to normality right now and just handle what we have in front of us, which is, this pandemic.
Yeah, I agree with you completely. And I think that to an extent, life isn't going to go back to the way it was.
Yeah.
It's things are there are some things that are going to be different forever. And I mean, I was saying to one of my colleagues, I think it's probably, I could definitely see a lot of people continuing to wear masks even after this thing is done. I think we're also just much more aware of illnesses and, in general. But yeah, I mean, it is mentally exhausting to be on guard all the time and to be worried all the time. But like I said, you've just got to stop thinking about yourself. There are doctors who are going into ICUs every day, and they are putting themselves in that position every single day to take care of people.
Yeah.
And I mean, the mental stress that they're under is insane. And a lot of those people are my friends, and I'm very happy to put up with isolation for a bit more, or limited social interactions for a bit more, if it means that they can be out of danger. And yeah, it's a communal effort, it's a collective thing, and just take a look at the people around you in your life, the people who you cherish, and just do it for them.
Yeah. And Daniel, just before we let you go, there's obviously been a lot of chatter about ivermectin and the treatment of COVID-19 using ivermectin. Can you give us a bit of background into the validity of that, and just your thoughts on the use of ivermectin?
Yeah, so I mean, this is my my personal opinion on ivermectin. So it is my view, but yeah, this is what I think of it. So I'm very skeptical of ivermectin. The studies, the bulk of the studies that have been done showing that it has an action against COVID, against the SARS-CoV-2 virus, have been in vitro studies. So they've been preclinical, preclinical trials, like in a lab setting using cells. It's really not. It hasn't been rigorously tested in clinical trials in the human body, which is what we call in vivo trials. The few clinical trials that have been done have been very short and very small, but very small. I mean, I'm talking 40 to 60 people. So really tiny, not long term. At least it needs to be, if it's a treatment plan like this, the study needs to go over a couple of months at least. I'm very skeptical of it. I wouldn't prescribe it. And I also am very frustrated at the black market trade. I was chatting to someone who says that from the Western Cape, who was saying that there are a bunch of farmers who are selling their ivermectin syrup that's for their sheep. And obviously the delivery system is going to be different in humans. It's been used in humans to treat scabies infections, but it is an anti-parasitic drug. I'm just very skeptical of it. I don't think it's really has enough data to support it yet. I would rather not take it.
And with that, thanks, Daniel, for coming in. If there's anything you want to close off on, just to reiterate a certain point, feel free to mention that now. But I will be linking your various social media platforms so that people, if they do have further questions, they can contact you, and then you can take it from there.
Perfect. Just one last point. There's one of the things that people are worried about, having, aborted fetal cells put into them. So the vaccines do not contain any fetus cells. You're not getting any human cells put into you. There is a human cell line that we use in labs. There's a couple of them that come from different people, where we have just kept the cells growing, and we use them for research and production and that kind of stuff. So the adenovirus that I spoke about in the podcast, that we use to house the DNA for the vaccine, for the Oxford and Johnson & Johnson vaccine, that adenovirus is grown and replicated and harvested in the cell line in these labs. So the cells are infected with the adenovirus, and then it's copied and copied and copied, and we harvest it from there. So that's what the fetal cells are used for, but it's not contained in the vaccine. I think just as a closing remark, I just want people to know that as the whole medical world, from medical scientists to doctors, the nurses, everyone, we are working as hard as possible to get this thing sorted, to protect the population. We care. We are really trying our best, and it's tough, and we need patience and compassion and just trust that we are doing our best. And the vaccines, I'm putting my personal seal on the fact that these vaccines are good, they're safe, they've been tested, they're reliable, and they are important, and they are what will make the difference. So think about it, reach out to me if you have more questions. There's a whole network of us who are very happy to assist, and let's beat this thing, guys.
Thanks so much, Daniel, and thanks for all the work that you and your team are doing. We really appreciate it. And for anyone who has questions, the links will be down in the description, so you can ask Daniel anything that's pondering in your mind.
Awesome. Thank you so much, Shannon.